Okay, today's integral looks a bit scary with all the big numbers, but it's actually not so bad, so long as you can see the u sub here. So the integral is the integral of x to the 1010 over 1 minus x to the 2022. And the u sub we want to do is u equals x to the 1011. And in this case, that would make du equal 1011 x to the 1010 dx. Now the reason we want to do this is because we can rewrite this integral as x to the 1010 over 1 minus x to the 1011 squared dx. And so now it's perfectly set up for the u sub. Basically, we don't have this 1011, but that's completely fine as long as we multiply by 1 over 1011 on the outside of the integral. It's going to work out. And so that will give us 1 over 1 minus u squared du. And now there's two ways you could go about this. The way I like to do is go pretty much straight to our answer by doing, so we have this 1 over 1011 out front, and then our answer would be arctan of u, and mu in this case is x to the 1011. And with that we would be done. The only issue with that is UNSW does not use that as their solution, so I'm going to go through it the way they like it, which is by partial fractions, which is not as nice, but it works. So by partial fractions, what we're going to want to do first is factor the denominator. That's going to turn into 1 minus u times 1 plus u du. And then I'm going to take it over here and just forget that it's an integral for a second, so that way we can actually do partial fractions with it. So 1 over 1 minus u times 1 plus u will equal a over 1 minus u plus b over 1 plus u. And so, to solve for a and b, what we're going to do is we're going to plug in with each, plug in 1 or we're going to plug in -1, depending on which makes each of these 0. So to solve for a, we're going to plug in 1 because that would make the denominator here 0. And so we're going to use the cover-up method. So because 1 makes this 0, or more specifically, 1 makes 1 minus u 0, so we're going to cover up 1 minus u, and we're going to plug in 1. So if we plug in 1 to the numerator, we're going to get that a equals 1. And if we plug it into the denominator, it will equal 1 over 1 plus 1, which is the same as 1 over 2. So a equals 1 over 2. If we do that same thing for b, to make the denominator of this part for b equals 0, it's going to have to be u equals -1. So this is 1 plus u. If we cover up 1 plus u and plug in -1, the numerator will be 1, so b equals 1 over. If we plug in -1 to the denominator, we'll get 1 minus -1, which is the same as 1/2. So both a and b are equal to 1/2, so I'm going to plug that back into our original integral. So we will have 1 over 1011 times the integral of 1, or not 1, of 1/2 over 1 minus u plus 1/2 over 1 plus u du. Now, what we could do is we could do each of these integrals separately, so we could essentially just split this into 2 integrals here. But don't forget this constant has to be multiplied by everything, so I'm going to do parentheses. And so now, if we simplify this, 1 over 1011 times, if we do the integral of 1/2 over 1 minus u, so this is basically a u sub, u equals 1 minus u, du would equal -1. So all we have to do is just put a minus here, and then our u sub works, and let's just do a u sub in our head and just integrate as it is. So the 1/2 is a constant that pulls out to the front. So when we're finished, we'll have this minus and this 1/2 out on front. And integrating 1 over u, or we're already using u, so let's just say 1 over w, that would be natural log w, or in this case, it'd be natural log of 1 minus u. Now for the second integral, 1/2 over 1 plus u. So that 1/2 will pull out to the front after we integrate. And then it would be another kind of substitution, 1 over 1 plus u. The substitution would be like, let's say t now. T equals 1 plus u, but we could just do that in our heads. The integral of 1 over 1 plus u will be the natural log of 1 plus u. And so now what we could do is both of these integrals have both of these logs in our answer have a 1/2 in them. So we can pull out that 1/2. So that will give us 1 over, so this is 1 over 1011. We're pulling out a 1/2. So this will turn into 1 over 2022. And then on the inside here, we have, it would be minus ln of 1 minus u plus ln of 1 plus u. By using log rules, we could simplify that down to ln of 1 plus u over 1 minus u. I'm just going to bring it up here to write it as our final answer. That would be 1 over 2022 natural log of 1 plus u. Don't forget u is x to the 1011. So 1 plus x to the 1011 over 1 minus x to the 1011. And just add your plus c, and that is your final answer.